Hey folks, in the last video we were going over some of these origin of the universe regions practice questions just to review some of the concepts from this unit. So in this video I'm just going to pick up where we left off and start with question 16. If you haven't done so already, make sure that you answer the questions on your own. That way you can compare your answers to this review. And if you haven't gone back and watched the first video, be sure to look at that one too. Since the first one was a little bit long, we'll go through about 7 or 8 questions here, depending on how long it takes, and then we'll finish up the rest of these questions during tomorrow's lesson. 16, I think this one is pretty easy. Which object in space emits light because it releases energy produced by nuclear fusion? Well, we know that fusion happens in stars, and therefore the only thing that is a star here would be Polaris, and we can find that on this table over here. We know that it's the North Star, planet, comet, moon. The Earth's moon does not create its own light. It only reflects light from the sun. Question 17, a major piece of evidence supporting the Big Bang Theory is the observation that wavelengths of light from stars in distant galaxies show A. Well, we know that it's a redshift, one of the big pieces of evidence for the Big Bang Theory. And since something is shifting in the red direction, over here, we know that it is increasing its wavelength. If something was blue shifting, then it would be decreasing its wavelength. I'm not sure why they don't call it violet shifting. If anyone knows a scientist, go ahead and ask them that. But for this one, redshift is appearing to make those waves of light appear longer. As distant galaxies and stars are moving away from us observers here on Earth. All right, question 18, a little interesting here. It says the graph shows the planet equatorial diameters and the planet mean distances from the sun. Neptune is not shown, and the question asks to place an X on the graph to indicate where Neptune would be based on its mean distance from the sun and equatorial diameter. So let's start with the x-axis, the mean distance from the sun for Neptune. So I'm going to be using this information here, right? Mean distance from the sun. So I want to find out where it's going to plot 4,498. That's going to be just about 4,500. So if I wanted to, I can go just barely to the left of that line. But if you want to go right on that line, that would be okay too. And the next one, we're going to look at the equatorial diameter of a planet. And the unit here is times 10 to the third power kilometers, or in other words, times 1,000. So when we're looking here, we see that the equatorial diameter is 49,500. So I'm going to divide that number by 1,000 and plot that 49.5. So that's going to be 40 right underneath 50. 49.5 is halfway there. So there's my mark. And sorry for this big old marker, sloppy marker that I have here, but it looks like I'm going to plot my point right there, or the direction said to plot an X. So that's where we'll plot Neptune on this graph. That was a tricky one, but we managed to get through it. It doesn't tell us to connect and finish the line, so I'm not going to do that for now, unless anything changes. Here we go, 19. The diagram in your answer booklet represents Earth drawn at a scale of 1 centimeter equals 2,000 kilometers. Centimeter markings along the equatorial diameter of Earth are also shown on the diagram. On the diagram below, shade in the space between the centimeter markings to represent the diameter of Earth's moon at the same scale. So we know that 1 centimeter equals 2,000 kilometers. So, get some of this stuff off the screen. We're looking at the diameter of the moon, and we know that 1 centimeter equals 2,000 kilometers. So what I'm going to do is I'm going to take this value here, which is 3,476, and I'm going to divide it by 2,000 to figure out how many centimeters I should be shading, and we get 1.7. So when we draw this, we're going to want to draw it. We can even start it right over here. So this is 1.9, 1.8, 1.7. I want to, I could just draw my circle right here. There's no need to draw it in the middle and count outwards. Oh, sorry, that's sloppy. But we want to make sure that that edge of the circle, well, first off, this edge is going to be starting right on the 0 increment, and that one is going to be at the 1.7 centimeter increment. Let's see here. We got more on this graph, so let's keep on going. It says the center of the asteroid belt is approximately 404 million kilometers from the sun. State the name of the planet that's closest to the center of the asteroid belt. So we just want to find the planet that's closest to 404 million kilometers from the sun. So is it going to be Jupiter or Mars? If we wanted to, we can subtract and find the difference. So Mars would be, let's take that 440 and divide it by the distance that Mars is, about 227. So that's about the distance that Mars is from the asteroid belt, 213. For Jupiter, we can take that 778 and subtract the 404, and we get a much bigger number. So it looks like Mars is closest to the center of that asteroid belt. So let's put on there Mars. All right. Looks like I'm going a little bit crazy. So we'll call it a day here. We'll continue with this review tomorrow, but as usual, I hope you found this video helpful. Hope you got some of these questions right, and I will see you folks next time.